what is HDFS. So usually we have a name node which stores some metadata, and then there are multiple data nodes which stores the actual physical blocks of the data. And the way we store is, instead of storing the entire file in one node, there is a concept of splitting up the data into the blocks and then replicating it across the cluster. And yarn framework usually is a way to process the data, and then so all of this architecture, it helps us to effectively utilize the cluster resources. Right, so that these are the two important things that we learned in the last classes. So today, absolutely. So data ingestion, like any data which is a relational data from the databases, it's a data ingestion.
Data ingestion from relational sources.
Absolutely. So today we'll see how it works, and we'll go into a lot of detail about scoop, and then we will also look into what is Hive, right? So these are very important topics that we are going to cover today. So let's get started with the MapReduce. All right. Now, sometimes there is, so sometimes a lot of people ask me, like, is it kind of another programming language? Because MapReduce, everybody thinks it's some kind of it's kind of a programming language, but the reality is it's not any programming language or nothing which is very specific to only Hadoop. Right? MapReduce is a model. It's not a language, it's a programming model. Right? And the reason for development of the MapReduce was because there was a need to process the data in parallel. Right? So it's kind of a model which is built purely for the parallel processing of the data, not within a node but across the node. Because parallel process and all these things, these concepts are very old and it's running since many years, right? Parallel threads and all of that. So this MapReduce is not that parallel processing. It is parallel processing across multiple nodes. So I'm not running multiple threads, but I'm running multiple processes which are running on different servers, and everybody coordinating with each other, and then finally working to achieve a single goal, which is to process a file in a much faster way. And this is not a new concept. I mean, the Google published paper in 2004, which means Google was already using it much before then, right? So it's a pretty old concept. Now, what we are going to learn today is there are two important concepts about MapReduce. So MapReduce is nothing but two phases in this model. The first one is the map, and the second one is the reduce. Right? So map is kind of it's one of the stage where the input data is mapped to some intermediate data. Okay, you take the input data, so you read a file, right, and you consider each record as an input record, and then you do something with it, so the output becomes some intermediate data which can be given to the reduce operation, and the reduce operation is responsible to segregate it and to make some logical grouping of the data, and then finally do some aggregation or reduction that we want to perform, the operation that we want to perform. Okay, so that's what a MapReduce. It's a two-step process. Mapping deals with reading the input data and creating some intermediate files or intermediate data. This intermediate data goes to the reducer, and then we get the final output. So if we have to understand this, let's say what was the need for coming MapReduce is, before 2004, the only way to process large amount of the data was using some very high-end server, and any server which is a high-end is definitely very cost effective, and there is a limit to which you can have the capacities are limited, right? You cannot have some infinite capacity of the servers, right? So that's what was one of the limitation, that if we had to process huge amount of the data, so there was no way to span it across multiple nodes. The only high-end servers were the only option. Now after that, we got the map reduce concept, which is a way to distribute the workload to achieve a goal of processing huge amount of data. So in a real life case, if let's say we have to deliver some couriers, right? If there's a courier company and there are so many documents, let's say there are millions of the document which has to be sent from senders to the receiver. So usually, let's say there is a big courier company which is having centers all across the globe. Okay. Now, usually, what happens? Each of the courier they will have some of their receptions at different locations, right? Everywhere there will be some way there will be some collection centers from which we go and we dump our documents, right? So this receptions you can think as a map. So what they are doing, they are taking each of the document and then they are kind of keeping along with them, right? So there's a map process to collect all of the input documents, or in some case we'll say it is taking it from the users or from the source and then putting it into its own local repository. And what it is doing after that, it is kind of grouping the documents together based on the destination, right? So let's say if consider the example, let's say there's an international courier company which gets document from all across the globe. So if all the documents which has to be sent to the India, they will be putting it in some sub a bucket which has to be go to India. All the one which has to go to US, they will be putting up all in the US bucket, right? And then all the documents which needs to go to Africa, they will be putting in the Africa bucket. So what are we doing? We are grouping the documents which needs to be processed together, and the Indian bucket will be sent to the Indian airline, and then the US bucket will be sent to the US airline, right? And then finally there will be a dispatch staff which will be dispatching it over there. So what did we do? We process a lot of data in a distributed way. And how did we distribute it? Because our collection centers were distributed, they collected all of the input documents together, and then based on the address they were logically grouped together, and then finally it was processed, which process means nothing but it was dispatched to the recipients, right? So that's how a map reduce also work, right? There will be a mapping phase and then there will be a reducing phase. In between, what is happening is a grouping of the data. Okay. All right. And if we have to take another example of a map reduce, the best thing is the way the polling booth work, right? So how does it work? Like there'll be tellers. So each of the lot of people cast their vote in each of the polling booths, right? And then based on they will be sending it out across each of the poll booth, right? So each of the poll booth counts are counted together, and final reduction is like based upon for each candidate how much of vote we got, and then the final election result is declared, right? So what we have input, a lot of people are casting their vote, all getting registered with a EVM machine, right? Or in a ballot way, it will be putting going in some boxes. And what we are doing in each of the counting center, they are counting the numbers, right? And then the final results are sent, and then at the final center, all of those things are aggregated, and then we get the final result. The same thing is how we are doing in a map reduce. The input data will be mapped, and then finally it will be reduced to get the final output. Now if you see, there are two types of the reduction happening. Some count happening at this level, at each of the booth level, right? And then there is a final level of aggregation which is happening at the center, the final counting center, where the data is further getting reduced. So this is two step, right? All the data coming in over here, there is a level of reduction happening at this level, which is count by each polling booth, and then the final count happening at the end, which is the final election results, right? So that's also how a map reduce works. Okay, so let's have an example of a real map reduce. So let's say one of the very famous example in a map reduce is a word count example. Okay, what is the word count? Let's say I have a file which has so many words. So this is my input file. Okay, it has so many different words, different types of words. Now what I need to do is I want to count the occurrence of each word. Okay, let's say for example this A. So how many times this A has occurred? If it has, or let's say, or let's say dog, right? So we see a dog over here and we see a dog over here. Right? There are two occurrence of the word dog, and this has occurred only once. Right? Similarly, quick, it has occurred only once. So if I need to find the count of all distinct word in this file, so let's see how we can do it using a map reduce. Okay, assume this is a very large file. This is assume the size of this file is 200 MB. Okay, so if the file is 200 MB, how many blocks is going to get splitted? 200 MB file.
It will be two.
Two blocks.
Yes.
2 blocks, right? So let's say these are the 2 blocks. Okay, the first block contains till over here, like till dog, and the rest of the data is present in the block number 2. Okay, and since I have 2 blocks, what I need to do is now I need to run the map reduce job. So mapping will also happen across in parallel, so 2 mapper can run together, right? Because I have 2 blocks, I can parallelly process these 2 together. Okay, now what I'm going to do in the mapping, I'm going to map each of the word with 1. So my key is going to be the actual word, and the value which I'm going to give is 1. Okay, like this. So this is what is my mapper's output. I'm taking each word, making it as the key, and the value which I am putting up is 1. So if you look into this, we are doing nothing. We are just putting each of the word as the key and the value as the 1 all over here. Okay, this is what is this is what is done in the map. Okay. All right. Now,
just one question here. We can see in the first statement there is no any redundant word discovering. Let's say if we are having dog 2 times in the first statements only, then in mapping it will come like dog, comma 1, dog, comma 1, and dog, comma 2 is the mapping itself.
sorry, I was not able to hear you, but I think you are not using earphones. That's why the voice is not going properly. So what you can do is you can either use the earphone or just put your question in the chat, because I was not able to hear and understand your question. Just put your question in the chat.
Is it good now?
No, it's not clear still.
Okay, let me put it in chat box.
Yeah, if you have a earphone, just use it, or you can put that in the chat. Okay. So okay. So I believe okay. So there's some questions. So let's wait for that. Okay, there's a question. What if we have dog 2 times in the first statement? Yeah, that's fine. See, that's not a problem. We can have any number of words in the first line. It doesn't matter. Okay, even if you have 2 dogs in the first line. No. Okay, good. So the question is like, if you have 2 dogs, will the map output will be dog 2? No. So map is just giving each word, and the value is going to be the 1. So it will be dog 1. Okay, let's take like this. Okay. the same thing. What he's saying is, if I had like this is dog is good, okay, and then next line is this is cat is good, something like this, right? So how the mapper output would be, so mapper output would be like this
It will be twice dog one.
yeah, that's right, it will be dog 1 and dog 1, okay, is 1 and good 1, that's how it will be. Okay, and for same thing for the second line also, so again this one and this way. Okay, now this will be your mapper output, and once the mapper is completed, we are going to have another phase which is known as a shuffling. Okay, so shuffling is a phase where there is a movement of the data happening. So it's something like if you just consider shuffling over here, let me just go back over here. So this is a shuffling happening, right? Like for each of the candidates, so we have to logically group the data for each of the candidate and give it so that we can assemble them together, right? So that's what's nothing but the shuffling happening over here, right? So same thing over here, if we have to shuffle the data, we have to logically put the data together, and then the final reduction, we can just count the occurrence of the word. Like over here, the dog, it became 2, because finally the reduction is nothing but to aggregate, right? Aggregate on what basis? Aggregate by the key. Okay, so the same
I
output.
have a question in reducing side. So it's reducing, that's absolutely fine. But how they will map the block information, because there is no block information in the reducing side. Can you please go to the previous slide?
Yes, over
Yeah, in here, A2, those are look like came under block 2 or something like that. Or?
okay, so reducer is not at all concerned with the block. It doesn't matter from which block the data came. It's absolutely not at all required, because this mapper output will be already sorted by the key, and it really doesn't matter whether it came from block 1 or block 2. For a end user, you gave only one file, right? Internally Hadoop split it into blocks or whatever it did. It really doesn't matter. What you gave input is a file which had few lines. The output what you are expecting is a count of each of the distinct words. So there is no need to have a block information in either mapper or the reducer. Nobody really cares about which block the data is coming from. Okay.
There is at the time of shuffling, actually, is there any ordering of orders happening? Words.
There is ordering in terms like automatically the mapper output will be sorted by the key. Okay, so in this example, if we have to sort, so let's say it will be sorted by the key. So if these are the keys, automatically once the data goes to the reducer, it will be by default sorted by the key. Okay, there is no other ordering. It's by default, it's sorting happens based on the value of the key, and that shuffling will not do that. Like while producing the mapper output, automatically the data will be sorted. So that's how the mapper output would be created. So shuffling wise, there is no any ordering and nothing such thing happening.
Why shuffling is necessary?
Very good question. Why is shuffling necessary? So shuffling is necessary because we have to bring the logical data together in order to reduce it. Say for example, in this case, right? So I have 2 dogs. So unless and until I bring this 2 dogs together, I cannot reduce it and cannot find out. Okay, let's say for example, this is one line. Okay, the second line is let's say this is mapper 1 output. Okay, and then mapper 2 output looks like this. This one, and then over here also let's say I have a dog 1 and cat 1. Okay, so what I have is I have two outputs. One is from mapper 1 and another one is from mapper 2. So unless and until I bring the data of this mapper or all the data for this dog and this dog together, right, I can never do dog and I cannot do 1 plus 1 plus 1 unless I have all the data for the dog together. So to bring the data together, I need to shuffle, right? And shuffle means this entries from this mapper output and this entry from this mapper output has to go to a reducer, one particular reducer which is going to add up together. Let's say this node, this mapper 1 is running on node number 1 and this is running on node number 2. Okay, and my reducer, it might run on node number 3, say for example. Okay, so what I need to do is I need to shuffle the data. I need to shuffle this dog, these two keys from this node number 1 and node number 2 and give it to node number 3 so that aggregation can happen over here, right? So that's what the shuffling phase.
Okay.
So
Yes, shuffling playing as an intermediate data.
Yeah, mapper output is the intermediate data.
Yeah.
It's just intermediate data. There is no use of it. It will be deleted once the reducer, once the reducer completes its job. This intermediate data will be deleted. It's just intermediate. Nobody is really looking at or consuming it.
So at shuffling phase, primarily looks like the data is being sorted, right?
Primarily, yeah, the data will be sorted by the key. That is true. So it's like this. If the same thing, if I have to shuffle, let's say how the shuffling will work. Okay, shuffling. So what I'm going to do is I'm going to group the data together. Like there will be a partitioning over here. We'll be go into detail, but let's say there will be partitioning. What partitioning will do? It will group the data by the key. So the dog 1, or let's say all the dog data will come together. So dog. What are the values for it? Let's say 1 to, okay, or what are the data? Like dog 1 is one set and then another set is dog 1 and the third set is also dog 1. Okay, and for is, how many sets is there? There is 1 and then there is another set of is 1. Okay, so this 2 is coming from over here, something like this, right? So what is this? Is partitioning of the data by the key. So we are kind of segregating the keys together, nothing but over here. If we again come back to the same discussion, right? So what we over here, if you see the courier company, we are grouping the logical couriers together, right? Or based on the address. So similarly, based on the key, we'll be grouping all the keys, the values for a particular key together. This is known as partitioning. And what shuffling will do? Shuffling is going to move the data. So if let's say reducer 3 is dealing with the dog, the key dog, so all this data has to go there. Let's say there is a reducer. So usually it will be like this: reducer 1, and let's say there is a reducer 2, and the key that it is dealing is okay. This reducer is dealing with dog, right? So all the data for the reducer has to go to the dog, right? So this is what the shuffling will ensure. This data goes to this one, and in the reducer 2 all the is data go to this one, right? So it will be getting is, and it will be doing 1 plus 1. Yes.
This will be only delimiter, or we can set a delimiter by our own as well.
Sorry, your voice is not clear. If you could type. Okay, I got a few questions in the chat. Let me take them and then I'll talk. So Jaydev is asking, space will be the delimiter. So space will be delimiter, or if you have any other delimiter, you can choose and you can decide in your mapping logic. right? So that you can say like, okay, if space is the delimiter or comma is the delimiter or pipe is the delimiter, you can specify in your mapping logic. Okay. I have one more question. How many mappers will be there? Very good. So this is a very good question. On what basis the number of the mappers will be there? Can anybody tell me like how many mappers will be there in this case if I have two blocks? 2. Okay, and if I have, let's say, if I have 500 blocks, then how many mappers will be started? I have a file which has a 500 blocks. So how many map process will be required for that particular file?
500.
500, right? But there is a little twist, okay? We will talk in a little while. So actually there is a concept of block versus input split. And this is one of the most important question. What is the input split? Okay, so